Hello, these are the answers to the group test that we did on Monday. Please go over your group test paper. Make sure that you have all the correct answers written in. I will collect this paper again and give you a final grade. So if you are missing some answers or if you had some incorrect answers, please correct them. Let's start with number 1, finding the perimeter of the shape below, and if x equals 3 and y equals 10. All right, so to find perimeter, we need to add up all the sides. So let's start by labeling the lengths of each side. Now for the square that's labeled y squared, each of the sides is equal to y. That's why it's named y squared, because remember that the tiles were named according to their area. So the area of this square would be y times y, which is y squared. The area of the rectangle xy is named that because one dimension is equal to y and the other dimension is equal to x. Now the shorter dimension here would be the x. So as I go to label my sides, we have y on the top and bottom of the xy shape, and then we have this side right here, which would equal x if it wasn't for that 1 that's down below in the corner. So instead of labeling it x, we're going to label it x minus 1. And then for this side of y squared, instead of labeling it y, we have to label it y minus x, because that's how much is being taken away from the shorter side of the rectangle that's connected to it. Now for this little unit square in the corner, each side is equal to 1. Now let me go around and add up all the different sides. So here we have y, 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 y. So far that's 4 y's. Here's another one, 5y, and here's a y. So that's 6y. And now let's add up the x's. Here I have a negative x, and here I have a positive x. Well, that cancels out. Those are opposites. So that makes 0. Now let's add up the ones. There's 1, 2, 3, but then there's a negative 1 or a minus 1. So 3 minus 1 would be 2. So the expression that represents perimeter would be 6y plus 2. Now we do know that y equals 10. So substituting 10 in place of y, I would get 60 plus 2. So the perimeter of this shape is equal to 62. Now let's calculate area. Well, area would be the 3 shapes, total area added together. The big square, y squared, would be the area. Well, y squared is going to be 10 squared, which is 100. xy means x times y. Well, x is 3 and y is 10, so we're going to multiply 10 and 3. So the area of that rectangle is equal to 30. And then the unit square has an area of 1. So the sum of those areas gives us the total area of the shape, which is 131. So those are the 2 answers for problem 1. All right, in problem 2, there are 3 different problems to do, A, B, and C, and our directions are to simplify. So what we're going to do is combine the like terms, those terms that have the same variable and exponent combination. Let's start by circling our like terms. So here I have a 9x, here I have a minus 4x, and this is a minus 2x. If I combined all those together, positive 9 minus 4 minus 2 would equal positive 3. So that would give me a positive 3x. Then I'm going to combine the constants, or the regular numbers. There's a plus 6, there's a plus 1, and there's a minus 15. So 6 plus 1 is 7, and then 7 minus 15 would equal negative 8. So that would be a minus 8. So there's the answer for A. It's 3x minus 8. Now for B, as I go to look for like terms, I have a 6y squared, I have a 2x, which has a negative sign, I have a 2x squared, I have a minus 7y, and a minus 11. And if I take a close look at that, I can see that each of those terms is distinct. Each of those terms is different from each other. If I was to lay out the tiles that represented this expression, they would all be different tiles. So there are no like terms to combine together. So this answer is already simplified. There's nothing we can do to make it more simple. So this is already simplified. Finally, for C, I have a 7x squared, and there are no other x squared terms, so that's not going to change. I have a minus 2x, and there are no other x terms, so that won't change. The only thing that will change are the constants. I have negative 5, negative 3, and positive 5. Well, negative 5 and positive 5 together make 0, so that leaves negative 3. So here's our simplified answer. 7x squared minus 2x minus 3. All right, problem 3 says to show 3 different ways to represent 0 on an expression mat using 2 tiles. Well, remember that we did this in one of our tasks. So here, let's draw 3 expression mats, and then we'll show using 2 tiles how we can combine to make a 0. All right, so let's see. How about if I have a unit square that shows the positive side and a unit square that shows the negative side, and they're both on the same side of the board? Well, that would make a 0. I could remove those from the board. How about if I had a unit square in the plus side of the region and also a unit square in the minus side of the region, and they're both showing the positive side? This would be 1 minus 1. Well, 1 minus 1 is 0, so yes, that would work. Also, I could have the negative side of that unit square showing in both regions, positive and negative. So in this case, I would have negative 1 subtract negative 1, but that still would make a 0. And if I were to move the tile from the top or bottom up to the other region, I'd have to flip them, and it'd have the same situation as we have in our first drawing. We'd have a plus and a minus on the same side of the board. So here are 3 different ways. And then the 4th way would just be to do the same thing here, except put them in the minus side of the region. So that would be a 4th way. Okay, on the back side of our handout, for this problem we're asked to simplify and then compare the 2 mats. Well, let's look for zeros. Let's see. I could take a tile here and a tile here. They're both the red side showing, but they're on opposite sides. One's on the plus, one's on the minus. I could slide those off the board. I have a shaded X and an unshaded X on the same side of the board, so that can be removed. And that's it. So let's move the tiles from the negative region up. If I do that, they will be unshaded. So I'll have a shaded X, which is a positive X, and I'll have 5 unshaded 1 tiles, which would be a negative 5. So the left side of this mat is equal to the expression X minus 5, or X plus negative 5, same thing. Now let's remove zeros from the right side. Well, here's a 0 right here that can go off the board. Here's another 0 that can go off the board. I could take a positive 1 and a positive 1 off because they're on opposite regions of the board. And I have a shaded and unshaded X on the same side, so that goes away. So let's see what I have left. I have a shaded X, which is a positive X, and I have a shaded 1, which is a plus 1. All right, so those are the 2 expressions, and I can see that X plus 1 is certainly more than X minus 5. So greater than will go like that. So X minus 5 is less than X plus 1. All right, the last problem is we have to find the perimeter of this shape and then see who was correct. Either James, who thought it was 6x plus 10, or Anna, who thought it was 6x. Let me see if I can zoom this in a little more. No, I won't be able to. All right, well, let's just go ahead then and label the best we can. All right, so first of all, if I have an x tile, and you know what, I think I might even just redraw this. Okay, so x tile means it's x on the longest side and 1 on the shortest side. And then I have 3 little 1s. Oops, actually I have 2 1s, but sandwiched between them is another x. Okay, and then I have an x at the bottom. Okay, so let's label all the sides. 1, 1, 1, 1, 1, 1, 1, 1. Now I need to label the underside of this top x. Now that side right here is not going to equal x. It's going to equal x minus 1 because we shortened it by 1. Same with this side right here. That's also x minus 1. And then on the tile that's going out to the right, we'd have the same situation. We have an x minus 1 and an x minus 1. All right, so let's go around and count all the x's. So I have 1, 2, 3, 4, 5, 6. So I have 6x. And now let's count all the ones. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I counted all the positive ones. That's 6x plus 10 so far. So it looks like maybe James was on the right track, but he forgot that we have these minus ones, and there are 4 of them. So we actually need to minus that from our expression. So our simplified expression should be 6x plus 6, not 6x plus 10. So James is wrong, and then Anna was also incorrect. All right, Anna apparently labeled all the x's, but she forgot to label any of the 1s. So she neglected that. So the correct answer actually is 6x plus 6. And we can't give a number for this because we don't know what x equals. So this will just be our answer, this expression. Okay, well that's all for this assignment. Please make sure you have all the correct answers and be ready to turn them in when I collect them on Friday. And remember, read some books.